Hello everyone. I will be explaining our DBMS project based on centralized banking system, also called ebankDB. Overview of our project is the centralized banking system is a database-driven application designed to manage essential banking operation using core DBMS principles. The objectives of our project is to implement role-based access control for different users, to ensure data integrity and security and consistency, to manage the customer accounts and transaction efficiently, the users of our project will be bank managers, bank employees, and customers. The core banking operations are the fund transfers, audit and security login, transaction processing, account creation and maintenance. The target users of the system are customers. The view account details and balances, transfer money to the other account, apply for new bank accounts, bank employees, create and manage customer accounts, monitor transactions, freeze or close customer accounts, bank manager, view audit and security logs, recruit and manage bank staff, review customer details, turn maintenance mode on and off. The technical requirements are for database, we have used MySQL, for backend, Java with JDBC and Tomcat, for frontend, HTML, CSS, and JavaScript. The queries supported by the database are list all beneficiaries added by the customer, check the status of recent fund transfer, retrieve account balance for given customer, retrieve transaction history for a specific account within a date range. The transaction queries update the account balance after transaction, retrieve transaction above the specific amount. Admin queries retrieve all accounts belong to a customer, list all active and frozen accounts, identify accounts unusually high transaction frequency. Securities queries maintain audit logs and of administrative actions, freeze accounts. The fixed deposit queries break a fixed deposit before maturity and calculate the penalty adjusted amount. Check the maturity amount and the maturity date. View all fixed deposit associated with a customer. The conclusion: the centralized banking system provides a structured and scalable database solution for managing real-world banking operations. AR diagram of our project. This is how our final database will, this is a blueprint how our final database will look like. These boxes represent the entities, for example, user, customer, employee, branches, manager, audit log, fixed deposits, account, transaction, and beneficiaries are entities. These also represent the attributes of our entities. The underlying attributes are the primary key for entity. These triangles represent is a relationship. For example, a user can be a customer and an employee, same like our employee can be a manager too. These diamonds represent the relationship between two entities. These numbers, for example, these 1 and n represent the cardinality. Let's take example. The customer and account is a one-to-many relationship because a customer can have many accounts, but account is designated to only one customer. These double lines represent the total participation. For example, this relationship, like branch maintains account, the account is in a total participation in this relationship. These unique attributes are the foreign key of entity. For example, account has a customer ID and branch ID as its foreign key.
In our database, we can see there are multiple tables such as user, customer, employee, manager. For our banking infrastructure, we have branch, account, beneficiary. For transactions and investments, we have transaction, fixed deposits. For security, we have audit log. In the user table, we have user ID, username, password, etc., which has user ID as primary key. The customer table has customer ID as primary key and user ID as foreign key, as it references the user. The employee has two foreign keys, which are user ID and branch ID, and employee ID is the primary key. In manager table, we have employee ID as foreign key and other information such as name, email, etc. The banking infrastructure has branch ID as primary key and IFSC has unique key. In accounts, we can see there are two foreign keys, customer ID and branch ID, and account ID is our primary key. In beneficiary, we can see beneficiary ID is primary key while customer ID is our foreign key, and it stores information such as beneficiary name, beneficiary account number, date, etc. The transaction ID as primary key, while account ID is our foreign key, which references the account table, and it stores transaction type, amount, transaction date, etc. The fixed deposit has FDID as its primary key, while customer ID, account ID as its foreign keys, as it references both customer table and uh, account number, and stores information such as account deposit amount and interest rate, start date and maturity date, and its status. The security has audit log, which has log ID as its primary key and foreign ID as employee ID, as it references the employee table, and it stores action done, action date, and with its description.
Queries that we have implemented for our project ebankDB. First one helps user to see a beneficiary with account ID 2. So as you can see, the retrieval was successful. Next one helps user to see their account. So here is only one account for customer with account ID 1. So this one helps user to see their transactions in descending order by transaction date. So as you can see, the transactions are in descending order by date. Next one helps user to get name associated with specific account. So here in the drop down, you can see Aman Gupta is linked with account number 2. And this one helps user to delete beneficiary. As you can see, deletion was successful. These are SQL queries for users who are employee. So first one helps user to see customers who don't have any account. So here you can see there are 3 users who don't have an account. Next one helps employee to get transaction summary of any account. So here you can see there are 2 transactions for account ID 1. And this one helps employee to freeze any account. So here you can see the status has been set to frozen. This one helps employee to activate any frozen accounts. So the account has been successfully activated. So here are SQL queries for users who are manager. This one helps manager to see customer details in form of a table. So here you can see the manager can see all the details for any customer. The same is done for all the employees working in ebankDB. So here you can see there are 3 employees. This one is a special feature only available to manager. As you can see, the account has been successfully closed. These are some triggers that we have implemented in our project. This one helps us to restrict any negative balance transactions or FD creation. As you can see, the transaction wasn't successful. As you can see, the minimum deposit amount is 1000 only. This trigger helps manager to see log transaction where the status changed by any employee is stored. So here you can see Ravi Kumar employee changed account status with account ID 1 from frozen to active. And this trigger helps us to block any transactions made by frozen or closed account. So let's freeze this account. So as you can see, the account is frozen, so transaction failed. So this trigger sets the date and time for any transactions made by any customer. As you can see, the date and time are already set. This trigger prevents any customer to add duplicate beneficiary. As you can see, there is Aman Gupta with account ID 2. Here you can see we get beneficiary already exists.
Conflicting transactions we can see when we are trying to do concurrent transfers from the same account. Like if we try to transfer in session A 40,000 from account 1 to account 2, and in session B at the same time we are trying to transfer 40,000 from account 1 to account 3, which follows a raise condition, and our account balance become minus 30,000, which violates our check that account balance cannot be negative. So to fix this, we can check before transferring money using select bank accounts from account where account ID is equals to just for update inside the transaction. So we can use lock mechanism. In our conflict in transaction to when happens when we are trying to create an FD when the account is closed. So here we can see the customer is creating an FD of 20,000 on account 3, but the manager concurrently closes that account. But the FD gets created, which is wrong. So we to fix this, we can try to use exclusive locks. In our conflict 3, we can see if we try to add duplicate beneficiaries. Like in session A, the customer tries to add an account number 999 as his beneficiary, and in session B, another account ID with same account number, which causes a problem since same account number, same beneficiary number cannot be given to two different beneficiaries. So to fix this, we can use unique constraint. In conflict 4, when we try to break an FD on a frozen account, in this we can see in session A, the person tries to break an FD, but the manager in concurrent session has frozen this account. But the problem happens that the account gets closed, which is incorrect. We can see here, which is incorrect. So we can also see check status before breaking an FD. In conflict 5, we can see during an active transaction when the accounts get frozen. So here we can see that we are trying to transfer 5,000 from account 2 to account 1, and an employee freezes our account, which causes the problem that the transfer happens, but the account was closed by the employee. Here we can see in the UI what is happening. In conflict one, when we are doing concurrent transaction, we are doing then there is a raise condition. In conflict 2, we can see when we are transferring uh, from a closed account we are and trying to make an FD, it causes a problem. Then when we are adding duplicate beneficiaries, it causes error. Then when we are when we are transferring from a frozen account, it shows error. Then we can see conflict 5 when the transfer gets frozen before the transfer gets completed.
Thank you. This project was made by Rishi 2024466, Parv Jain 2024408, and Satyajeet Singh 2024513.